Good afternoon everyone, welcome to the channel. In today's video I want to show how we can perform image manipulation using a library known as PIL or Python Imaging Library. So let's get started. I want to show a few operations. This is a big library. I don't want to show all the things that can be performed. So let's at first import image module from PIL library. So we have to write from PIL import image. Okay, so I have a couple of images in my directory. Let's show the first one. So I have a squid image. So squid.jpg. Let's see this image. So this is the squid image that I have uploaded in my current working directory of Jupyter Notebook. So it's a little bit big to fit in the window. So let's reduce it. At first check its size. So let's check image size. So we can simply type this and this will give us height and width of the image. So sorry, I have written it wrongly. This is width and height, not the other way around. So 4000 pixels along the width. So you can obviously this is longer than the height part, and 2250 height we can confirm from this as well. So 4000 width, height 2250. Okay, now let's check the file name of the image. So we can do it using this. So basically this is the name of the file of the image, squid.jpg. We can also check file format. Format. So it's JPG or JPEG file. So now let's check pixel format of the image. So img1.mode. So this is a color channel, we can obviously see. So its mode is RGB, red, green, blue. Now let's resize the image to make sure it fits in our window. So resize the image. So let's create a res variable img1.resize. So currently we have 4000 by 2250. Let's reduce the width to 800 and height to 400. Let's check. Okay, let's see. Yes, I think it fits in our window now. So these are a bunch of squids. Okay, now let's rotate the image. So let's create a variable and we can simply call the rotate method. So it's rotating by 10 degrees. So this is in 0 degree, so it got rotated by 10 degree. If we take 20, it gets rotated even more. Okay, now change image file format. So we can change the image file format according to our wish. So currently res dot format img1 dot format is JPEG. So we can obviously change it. So let's create another variable. So img on dot save, and we can just mention squid dot png. So currently we have JPEG format. Now we can change it to actually we do not need this variable. This one is okay. Squid dot png. Now let's say we want to open it. Squid dot png. So we have already saved this same JPEG image in PNG format. Now we can also view it. So this is actually, so can we check format? And now it's PNG. Okay. Now 9 extract individual image bands. So these are the individual image bands. So we have already raised, I guess. So raise, yes. So we can call split, and just to see the difference I have to first display the resized squid image and now the new image. So image dot merge. So RGB, and we can change it. So instead of RGB, let's just mention BRG. So blue, red, green. Okay, now let's first see this image, then the same image, but bands have been switched a little bit. So now we have blue, red, green instead of RGB, BRG. So we can see now it's kind of reddish. It's more purple and it's kind of reddish. You can also see another one, I guess. So instead of BRG, let's say GBR, and also change its name to 2. Okay, now we had red on, now we got a green on, and I actually like this one. Some of you may like this one. Okay, so this is how we can, oh, I forgot to, so we can mention create new multi-band images. So after we extracted individual image bands using this split method, then we in this case we created what to say, new multi-band images. Okay, then after that so 10, 11. Now let's combine two images. So for that we need to at first open a new image. So I have another image in my working directory, that is a fish image. Let's see that on. Okay, so this is a fish image. So this was a squid image, now it's a fish image. Okay, it also doesn't fit in our window, so let's check the size. I think same size, so let's just dot resize. We want to make it the same size, 800 and 400 raised to. So I think now it fits our size. So this is a fish image. Now let's check size 0 raised to size 1. So 800 and 400. So size 0 is basically the width, raised to is basically the height. And for combining two images, so we have to combine two images. So for this reason we can do this like that. So image dot new. So we have to mention the mode, and this is the size. So raise size 0, 2 times raise size 0 and raise size 1. So raise size 0 is 800. So this is basically 1600 and 400 size. So we want to combine two images side by side horizontally. So after that combine dot paste to provide the first image. Race is our first image, the squid image, and we have to mention the pixel position. So pixel position 0 0. But in case of second one, raise 2, raise dot size. So raise dot size is 800. It will the second one will start where the first one. So first one is this one. This one is the first one. So second one will start where the first one ends. So that's why raise size 0, and then we do not need to change the height. Height is same. Now let's just visualize it. Now we can get it. So height of the both images is same, but it starts after it ends. That's why raise size dot 0. And we can do the opposite as well. Instead of side by side, top to bottom, we can also do that. So let's copy this again so that it's easier to understand. Then copy. So in this case we have to change few things. Instead of this one we have to mention 2 here. So multiply and let's just mention it as combined 2. Also copy these 3 lines. This will be 2. So we need to change here as well. So now this will start 0 and raise to dot size. This will be 1. So now we have top to bottom. This one comes at top, then this one starts after that. Okay, now let's crop an image. So let's first show this image. This is our image. I'm going to crop a portion of this image. So this is how we can do that. So let's create a variable raise2 dot crop. Let's 60. So the notation is like this: left, top, right, bottom. You can play around with these values to see what kind of output comes. Cropped. So we have basically cropped just around this part, this fish, from this raise2. Then apply filtering on an image. So for that we have to import image filter module. So from PIL import image filter. So we want to blur the image. Let's say blur 1. So raise dot filter image filter dot blur. Let's see what does it do. Okay, I think it's better if we show raise first. So this is raise and this is blurry version of raise. Just look at this one, then look at this one, and I think stones make it more clear. This stone is clearly visible. This looks blurry. We can also show another type, I guess. So sorry, not another type, just for the other image. So this is our raise2. Let's just do it from that on. This one is a lot difficult to understand, but I think you can get it. Just look at the stone. So this is more clear and this is obviously blurry. Okay, now let's see another type of filtering. Contour raise2 filter image filter dot contour. So you can also play around with different. So there are so many options. I do not want to show all of them. Let's contour and see what it does. So you can see, just look at this image and then look at this image. I think it just draws like body shapes or something like that. Okay, now flip an image. So let's say flipped one. Transpose image dot from left to right. Flipped one. Okay, I think let's bring rays again to see that. So you can see side by side on the left, now side by side on the right, because we have flipped from left to right. I think we can do top to bottom as well. So top to bottom, let's make it 2. Now we can see it's upside down. I think we can do another one. So 3. We have a rotate option, I guess. So let's say rotate. Now it has moved 90 degree. So just 90 degree like that. Okay. Now finally I want to show one more thing in this video. So we can also create an image from numpy array. So it's image. So at first we need to import numpy array and set the random seed and create a multidimensional array. So np dot random. So this is just a random noise. Let's make it 200 by 200 and array. Okay, so this is just a random noise. We can also check the shape. So this is 200 by 200, and now we can convert it to image, array to image. So image dot from array, we need to just pass it, and mode will be L. So this is grayscale images, and if we want color, then we can just mention the mode as RGB. So this is from this this is the random noise, and this is the grayscale image and color image of this random noise. So we can create image using this PIL module, and we can create an image from numpy. So that's the end of this video. This is a big library, so there are plenty of other functions, but I do not want to go in there. You can check the documentation if you're interested. Okay, so that's the end of this video. Thanks for watching.